Yeah.
Yeah.
Okay. So solving radical equations. Now, by the way, radicals isn't just square roots. It's cube roots and all that good stuff. Always starts with, and you can write this at the top if you want something to study from. It starts with step 1, isolate. I'm not going to say the radical. I'm going to say a radical. Because there are problems if you look at examples 3 and 4 that have 2 of them. And it really doesn't matter which one you isolate, but isolate a radical. So in 1, there's only one way to do that. Add 2 to both sides. And then if it's a square root, you square both sides. If it's a cube root, you cube both sides, so on and so forth. So square / cube / whatever, both sides. So we're going to cube both sides here. And this ends up being pretty straightforward. We just end up solving whatever's left. So in this particular one, when I cube both sides, what kind of equation is that? Linear, quadratic, exponential? It's linear. And these are the nice ones that just end up being linear. So it's a, at most, 2-step process. 2x equals 12, x equals 6. You definitely want to check for extraneous roots with radicals. So a quick check here, 2 times 6 is 12, 12 minus 4 is 8, cubed root of 8 is 2, 2 minus 2 is 0, this one checks out. So you're good. But there definitely will be extraneous roots that show up. Okay? Number 2 just gets a little bit harder. Isolating the radical is fine. But can you look at it and tell me why you already know it's going to be a little bit harder? Right. When you square both sides, it's not just a number you're squaring anymore. But yes, the x. So you square both sides, you get 2x minus 1, and you have to FOIL this out, or hopefully we're getting better at the shortcut, x squared minus 4x plus 4. And then subtract 2x over. Add 1 over, because this is a what kind of equation? It's not a linear this time. Right. Because we had to square out an x, as I think JR said. Was it JR or was it Tommy? Okay. Because there was that x, and it does make it harder, because now it's a quadratic and not a linear. So we're going to factor or use the formula. This is factorable. What factors? Go ahead.
X minus 1 and x minus 1.
Very good. X minus 1. We know it's the same sign because it's got to multiply to get a positive 5. Good. And so you tee it up. You get x equals 1 or x equals 5. Again, you definitely want to check each of those. So if I plug in 1, I'm going to get 2 minus 1 is 1. Square root of 1 is 1. 1 plus 2 is 3. Is that right? Yeah. No. 1 doesn't check out. If I plug in 1 to my left, I get 3. If I plug in 1 over here on the right, I get 1. So does 3 equal 1? Are we following that?
Yeah. Well, I was just saying
Right. Yes. I got 3, but does 3 equal 1? Because I also have to plug that in there. No. So that's extraneous. 5 plugged in. 2 times 5 is 10. 10 minus 1 is 9. Square root of 9 is 3. 3 plus 2 is 5. 5 equals 5. That one does work. Okay?
Are you going to ask us to check it like that on the test? Or is that just...
Oh, yeah, you absolutely have to. Because if you don't, you'll end up telling me that this is a solution. And it's not because you did anything wrong in the solving process. So, like, when you first start checking in Algebra 1, it's because you're checking for mistakes. In advanced level math, you're checking because kind of weird things can happen with these more complex problems. Andrew?
Do you have to write extraneous or can you write reject?
I'm just crossing it out and not circling it, yeah. Just cross it out or really circle your only final answer, something that points out that at least you processed it. All right, 3 is going to step it up a notch because here we have 2 radicals. So again, we're not isolating the radical. I said a radical for this reason. I'm going to say I'm going to isolate this root 3x plus 1 simply because it's already positive. I like to keep things positive. So I have to add this one to the other side. You did these last year. They're just a little bit more of a pain. Because now not only is there an x involved on the other side, but there's a radical involved and a binomial involved, so it can be pretty messy. But we're still going to go ahead and square both sides. But again, when you square a binomial, you have to FOIL. So the left side is pretty easy. The radical is just going to cancel. But the right side, and I'm not going to even myself try to take a shortcut with this one, I'm actually going to write it out and FOIL it. So we have a 2 times 2, which is 4. We have a 2 times the radical, which is just plus 2 times the radical. Then we have another plus 2 times the radical. And then radical x minus 1 times radical x minus 1 is just x minus 1, so plus x minus 1. Now, if we combine like terms on the right, we end up with 3 plus 4 of these root x minus 1s plus x. So, example 1, once we squared both sides, was a linear. Example 2, once we squared both sides, turned into a quadratic. What type of equation is this still? It's not linear, it's not quadratic, it still is a, what was it? It's still a radical. The benefit here now is that now we only have one radical and not the initial 2. So it's gotten better, although it looks longer and uglier. It has gotten better because now we have only one radical instead of 2. So we just repeat the process over. Isolate the radical. So I'm going to subtract this 3 over, and I'm going to subtract this x over. And then we have to have another conversation. Because normally I would say continue to isolate the radical by dividing by 4. And in some cases, I'll want you to do that. Here I'm a little hesitant because if I divide by 4, I'm going to create fractions, which is another scary, dangerous beast. No one really wants to square fractions, right? That to me is like a recipe. So if that division is going to create fractions, I would recommend you steer clear of it because it's just a little bit more risky than what I would prefer you to do. And I would prefer you to square both sides here. And there still is a risk because I know you guys don't, a lot of you wouldn't think this way, but when you square this side, I'm going to throw it in parentheses. Squaring the left is a binomial. I'm going to put that in parentheses too. But I get a little more nervous. Squaring the binomial is a little bit of work, but it's more straightforward. We do it a lot, so you're used to it. Squaring this makes me nervous because a lot of people are going to forget to square the 4 as well. So when the 4 gets squared, that's a 16. When the radical x minus 1 gets squared, that's just an x minus 1, right? And because it's a binomial, it has to be kept in parentheses. So either way, this problem is going to be tricky. I just think it's less tricky. It's easier to remember to square both pieces than it is to have to square a fraction, I think. But if you want to divide both sides by 4 and square fractions, you can. It's just, I think it would be a little bit tougher. Neither's easy, I would say. So on the left-hand side, when I square that, I'm going to get 4x squared minus 4x minus another 4x is going to be minus an 8x plus a 4. And this is a quadratic. So I'm going to distribute that 16. And then I'll get this whole thing equal to 0 so I can solve it. Subtract my 16x over. Add my 16 over. 4x squared minus 24x plus 20. Now, method of solving this quadratic. Make your life easy. What did you do first?
Take a 4 out.
And you don't even have to factor out of 4. because it's not a factoring problem necessarily. There is an equal sign, so you can just divide both sides by 4, and then you don't even have to think about it. X squared minus 6x plus 5. See, if it was an expression and it said to simpler or factor the expression, you would have to leave that 4 out in front. But because this is a solving problem, you can divide both sides by 4 and be done with it. And then we're just x minus 5, x minus 1. So you get x equals 5 or 1. And then we have to check. Take a minute on your own and check 5, and then check 1 and see if we have to reject any or both. Check them, Ryan?
Yep.
What do you think?
Cross off the 1.
Really?
Yeah, really. Yeah, I did it in my head.
Be careful of that, though, because there is a lot to keep track of by the time you take the square root of the first expression and then have to take the square root of the second expression. Because the first one, when you plug in 1, gives you the square root of 4, which is 2. Minus, when you plug in 1, 1 minus 1 is 0, the square root of 0 is 0. 2 minus 0 is 2, that works.
I thought that was just like 1 instead of 0.
Gotcha. So they do both work. All right, those are the complex ones. We got one more to practice. This one, I just, unfortunately, I have to subtract over something. So, whereas this one I added over something and it kept, I don't think it's going to be that much more challenging because I have to subtract, but if I had a dime, the number of times my lead broke today, 0.7 millimeter paper mate. Garbage can. Is it? It's not a paper mate. Yours the big. It's better. Something about the paper mate. You have the paper mate? Yeah, it breaks all the time. I'm going to confess, someone left this on the floor on Friday, and any math teacher is never going to let a mechanical pencil go to waste on the floor. But I should have. The point is I should have. Or I should have taken the lead out and put it in a different bic. That's what I should have done. All right, so from here, go ahead and square it on your own, and then we'll see if we all end up in the same spot. And whenever you're done, you can look up at the screen and see if you, I didn't combine like terms yet, but just the squaring initially on the right should give us that. Are there any questions on that? Because that's a trick in and of itself. Now I'm just going to re-isolate the radical. So I'm going to subtract this 1 over. I'll do it all at once. I'm going to subtract this 2 over. So that's gone, and I'm going to subtract this x over. So I get 2x. 7 minus 3 is plus 4. Now, actually, come to think of it, this one works better. Because dividing by -2 here is actually no big deal, right? Both of those numbers are divisible by 2 so that I wouldn't actually have a fraction. So if I'm going to do that. That'll give me -x minus 2. Now maybe you don't like the negative signs, but I can live with that versus a fraction. And now when I square both sides, I'm going to be a little bit careful here when I square. Negative x squared is just x squared, right? My outer and my inner, if you guys can visualize this, negative x minus 2 times negative x minus 2. The outer is going to give me 2x, and the inner is going to give me 2x. It's actually going to be plus 4x plus 4, which is actually, just side note of interest, that's the same thing I would have gotten if I had squared x plus 2. Can you guess why?
You square a negative, so it's going to be positive.
Right, because x, if I negated x plus 2, then it would be that. And if you square that, the negative squared is going to be positive anyway. Good, Ryan. Anyway, that was just a side note because I thought that was interesting. And x plus 2. Then we solve the quadratic, so subtract your x, subtract your 2, and we're almost ready to call it a day. Is this factorable? Oh, sweet Lord. It's not, is it? I don't like this one. This is going to end up, well, maybe it's not going to be extraneous. It is? Plus 2 plus 1, thank God. Okay, x plus 2 plus 1. I don't know why I was in my own head. This one's got me all hot and bothered because I'm really nervous. Oh, I'm not nervous. But some funky things are definitely happening as we square these negatives. So I'm thinking these might be extraneous, but I don't know. One of them is? So which one works, Andrew? Negative 2, because I get negative 6 plus 7, which is 1. Square root of 1 is 1. Plug in negative 2, I get plus 0 is 1. So yeah. The other one gives me, what does it give me? 3 equals 1? Right. So, oh God, negative 2 worked, right? All right, so your homework. You want me to mix it up? All right, I'll mix it up. Fives, nines, and ones. You got it.
5, 9, what?
Yes.
1's 5, 9.
Ones, fives, and nines.
Can we do it on the paper?
Sure. There's room. There is. All right. Can you do me a favor and look at 129? Is that one going to get you hot and bothered? Because I might do that one with you.
You should just not do it.
No, you got to do it. Because, I mean, obviously the first couple here, guys, are going to be a review of rational. You have a test coming up, so that's fine. Then there's your chunk of radicals that you've been doing. What did I just say? 1s, 5s, and 9s?
Yeah.
So your radicals, no problem. 25 is not a radical. It's just a linear. It's just long and crazy, the simplifying. I'm not really worried about that. But 129, I feel like might mess with some of you. Or you'll overthink it. What kind of equation is this? That we just it's absolute value. So using that same logic that we did the other day, whatever's is that the absolute value is already isolated. Whatever's inside there could equal what? 12 or negative 12. So what's a little bit different about this is it's just you've branched it into 2 quadratics as opposed to 2 linears. So 2 linears is going to give you 2 answers. 2 quadratics is going to give you 2 answers per quadratic. So potentially 4 answers that you got to check out at the end. So no big deal. Just solve your quadratic. Subtract your 12. That's factorable, so you should be fine from there. add your 12 over on the other one. That's also factorable, so factor them both, tee them both up, have 4 solutions, check them.